रात और स्क्रीन की रोशनी, सिंटैक्स की उलझन, प्रांशु का ज्ञान, एक एक लॉजिक आराम से समझाना। हाँ, मैं हूँ तुम्हारा गाइड यहाँ। ये डिजिटल सफर अकेले नहीं, लेट्स डिबग इट टुगेदर माय फ्रेंड। ये डिजिटल सफर अकेले नहीं, अकेले नहीं।
Tech with Pranshu, C Programming Series, Episode 1, Introduction to C Programming. Welcome back to Tech with Pranshu. In the previous video, we outlined everything this complete C Programming series is going to cover. Today marks the beginning of our actual first lesson. In this episode, we will cover the basic introduction of C Programming, its history, why the language still matters, its advantages, its disadvantages, and the fundamental structure of a C program. By the end of this video, you will be able to read a simple C program and understand exactly what every line is doing. Let's get started. 1. The history of C programming. The C programming language was developed by Dennis Ritchie in 1972 at Bell Laboratories. It was created as part of the effort to redesign the Unix operating system, which had originally been written in assembly language. Assembly gave the Unix team full control over the hardware, but it was tedious to write and impossible to move from one machine to another without rewriting almost everything. Ritchie and his colleagues wanted a language that combined the efficiency of assembly with the readability of a higher-level language, and C was the result. C itself evolved from an earlier language called B, which was developed by Ken Thompson, and B in turn was influenced by a language called BCPL. Once C matured, the Unix kernel was rewritten in C, which made Unix one of the first portable operating systems in computing history. This portability is a major reason C spread so quickly across universities, research labs, and eventually commercial computing. Even though C is now more than 50 years old, it remains one of the most widely used languages in the world. It regularly ranks among the top programming languages in global usage indexes, and it continues to power the software that runs beneath almost everything else you use on a computer. C is often called the mother of programming languages. This is because a huge number of modern languages borrow their syntax, keywords, or core concepts directly from C++, added object-oriented features on top of C's syntax. Java borrowed C's curly brace structure and many of its keywords while adding automatic memory management. C# did something similar for the .NET ecosystem. Even languages that look quite different on the surface, like Python and JavaScript, still carry traces of C's influence in their control structures, such as if statements, for loops, and while loops. Understanding C, in other words, is not just about learning one language. It is about learning the shared foundation beneath dozens of other languages. 2. Why learn C programming today? A fair question at this point is, why learn a 50-year-old language in the era of Python, JavaScript, and AI-assisted coding? The answer is that C teaches you how computers actually work underneath the abstractions that modern languages hide from you. When you write Python, memory is managed for you automatically. When you write C, you manage memory yourself, which means you are forced to understand what memory actually is, how variables are stored, and how a computer's processor executes instructions step by step. Once you understand C properly, moving to other languages becomes significantly easier. Concepts like variables, data types, functions, loops, arrays, and pointers appear in nearly every programming language that came after C. If you learn them well here, you will recognize them instantly everywhere else. C is, in this sense, the base layer of your programming foundation. Skipping it does not stop you from becoming a programmer, but learning it makes every language you learn afterward easier to master. C is also still directly employed in industry. Operating system kernels, embedded systems in cars and appliances, device drivers, and performance-critical software components are frequently written in C or C++, so the language remains professionally relevant, not just academically interesting. 3. What type of language is C? Programming languages are generally divided into three categories based on how close they are to hardware versus how close they are to human language. Low-level languages, such as machine code and assembly language, are extremely close to the hardware. They give you precise control over the processor and memory, but they are difficult to read, difficult to write, and specific to a particular type of hardware. High-level languages, such as Python or Java, are closer to human language. They are easier to read and write, and they hide most of the hardware details from the programmer. This makes development faster, but gives you less direct control over what the machine is doing.